In this video, I'm planning on talking about how to name ionic compounds. And first of all, what is an ionic compound? An ionic compound is a compound made up from a metal and a nonmetal. So the first step in naming your compound is first of all figure out if you even have an ionic compound. Remember, there's ionic compounds and there's covalent compounds. And so the first thing you want to do is figure out, okay, well, I'm just going to write down a few, like let's look at this compound first. So we have potassium and we have iodine. So the first step in figuring out how to name this is first of all figure out if this is an ionic bond or a covalent bond. And to figure that out, we need to figure out, okay, do we have a metal and a nonmetal, or do we have two nonmetals? Because remember, if you have two nonmetals, that forms a covalent bond. So what we want to do is look at the periodic table and remember that the metals are over here and the nonmetals are over here. So if we look at this, we have potassium, which is right here. So potassium is a metal. And we have iodine, and iodine is right here. So that, and this area of the periodic table is nonmetals. So that means that iodine is a non-metal. So we know that we have a metal and a nonmetal. So we know that this is an ionic bond between these two elements. And so now what we do, so that's the first step. We figure out what kind of bond we have. Do we have ionic or covalent? We have an ionic bond. So I'm going to just put the steps here. So one, metal plus nonmetal, or nonmetal plus nonmetal. And this first one means that it's an ionic bond, and the second one means the nonmetal plus nonmetal means that it's a covalent bond. So now what we want to do is to name this, all we need to do is for ionic compounds, all we need to do is write down the name of the first element. So in this case it's potassium, and then we write down the name of the second element, only instead of writing the full name, so we'll take the first syllable of the name and add "ide" to it. So since we have iodine here, this would be iodide. So the way that we name this is we have the first element, and this is the metal. So the first element is the metal, and then we take the second element and we use the first syllable of the name plus IDE. And I have a summary of the different negative ions here. So for instance, if we have phosphorus, this would be phosphide. If we have nitrogen, it would be nitride. If we have sulfur, it would be sulfide. If we have oxygen, it would be oxide. If we have iodine, it would be iodide, like we saw here. If we have bromine, it would be bromide. If we have chlorine, it would be chloride. And if we have fluorine, it would be fluoride. So let's go ahead and do another example. Let's look at, so let's say that we have magnesium and bromine. And let's look at two examples. We also have aluminum and oxygen. So for this first one, the first step is figure out, okay, is this, and I'm going to actually write the other steps here. So first of all, we figure out if we have a metal and a nonmetal. And if we do, we have an ionic bond. If we have two nonmetals, then we have a covalent bond, and then we need to use different naming rules. But for what we're doing here, we're doing the naming rules for ionic bonds. So the first step is figure out what kind of bonds you have to figure out if you have an ionic or covalent bond. And then the second step is write the name of the first element. This is the metal, plus the first syllable of second element plus IDE to its name. So I'm going to move these down. So for this first one we have, let's just look at the magnesium and bromine. So we have magnesium and bromine. And so the first step is we want to figure out, okay, is this an ionic bond? So we have magnesium, which is a metal. It's right here on the periodic table. And we have bromine, which is a non-metal. It's right here on the periodic table. So we know that we have a metal and a non-metal. So we know that this is forming an ionic bond. So now what we do is just name it. So the first step is to write the name of the first element. So we have magnesium. And then we use the first syllable of the second element and add "ide" to its name. So we have bromine, so that's going to be bromide. So this is magnesium bromide. Now let's do a couple more. Somebody erase this. Let's say we have aluminum and oxygen. So what we want to do, we're given this compound and we want to figure out what the name is for this. So first of all, we need to figure out if we have an ionic or a covalent bond. So aluminum is a metal. It's right here on the periodic table. And oxygen is a non-metal. It's right here on the periodic table. So we have a metal and we have a non-metal. So we're going to use the naming convention for ionic compounds. So what we need to do is write down the name of the first element. So that would be aluminum. And then we write down the first syllable plus "ide" for the second element. So oxygen, we have oxide. So this would be aluminum oxide. Now let's do this one. So we have Mg3N2. So the first thing we want to do is figure out, okay, is this an ionic bond? So we need to check, is this a metal and a non-metal, or is this two non-metals? So we have magnesium, which is right here on the periodic table. So this means that this is a metal. So magnesium is a metal. And we have nitrogen, which is right here on the periodic table. So nitrogen is a non-metal because this is where the non-metals are. So remember, the metals are here and the non-metals are here. So what we want to do is write down, so we have a metal and a non-metal, so we have an ionic bond. So what we want to do is write down the name of the first element. So this would be magnesium. And then we write down the name of the second element, plus we add we write down the first syllable of the name of the second element plus "ide." So for nitrogen, this would be nitride. So we have magnesium nitride. Now let's do this one. So we have Ga2S3. First of all, we want to figure out if we have an ionic bond with these. So do we have a metal and a non-metal, or do we have two non-metals? So we look up gallium on the periodic table. I don't have it written in, but it's actually right there. So this is a metal. So gallium is a metal. And sulfur is a nonmetal. So we have a metal and a nonmetal. So this means that this is forming an ionic bond. So now what we want to do is write down, so we go to the second step. So write down the name of the first element. So we have gallium. And then we have sulfur. So we have the first syllable, which is sol, and then or sulf, and then we add ide to the end of it. So we have gallium sulfide. So now I want to add another rule to this. So all of these compounds that we've named so far, we've been using ions that only form one variation of their charge. So for instance, all of these ions in this first column, so lithium, sodium, potassium, rubidium, and cesium, these are all going to form a +1 charge. All of the ions that I have here, so beryllium, magnesium, calcium, strontium, and barium, these are all going to form a +2 charge. So you're not going to see a variation of, say, the charge with magnesium. Magnesium is always going to have a +2 charge. And then coming over here, so fluorine, chlorine, bromine, and iodine are always going to have a -1 charge. Oxygen, sulfur, and selenium will always have a -2 charge. Well, it turns out that some elements can form ions with more than one charge. So for instance, iron, which is right here, can form a 2+ charge and a 3+ charge. So we can have an ion with Fe2+ and Fe3+. So it turns out that if we have an ion or an element in our compound that can form more than one charge, we have one more rule for naming our compound, and that is that we put a Roman numeral in indicating what the charge is on the metal. So for instance, if we have, let's say that we have Fe2O3. So if we go by the rules that we were just using, first of all, we would figure out that we have a metal and a nonmetal, so we have iron and oxygen. And we would write down the name of the first element, which is the metal, and then the first syllable plus the second element plus ide. So this would be iron oxide. But the problem is, based on the name, we don't know if iron is an ion with a 2+ charge or a 3+ charge. So really, this can form a couple different compounds. It can form iron 2 oxide, so this can form iron 2 oxide, or iron 3 oxide. So we need to add a rule here, and I'm going to erase some things. But what I'm going to do is, after this first rule, so once we figure out if we have a metal and a non-metal, so if we figure out that we have an ionic compound, the next thing we need to do is determine if the compound is made up of ions that can have more than one charge. So can ions have variable charge? If yes, we need a Roman numeral after first ion, indicating charge. And then no then we go back up to here, and it's just what we were doing previously. If yes, then we do what we were doing previously, only we write a Roman numeral after the first ion indicating the charge. And I'm going to do a bunch of examples showing how to do this. Your first question might be, well, how do we know if it has a variable charge? Well, you might not always know without looking it up. There's a few clues though. A lot of the transition metals in here can form variable charges. And tin and lead, even though they're over here, they're not really a transition metal, they kind of behave like transition metals in that they can also form variable charges. So the ones that we know for sure, like that don't form variable charges are, for instance, lithium, sodium, potassium, rubidium, and cesium always form a +1 charge. Beryllium, magnesium, calcium, strontium, and barium always form a +2 charge. And then fluorine, chlorine, bromine, and iodine always form a -1 charge. Oxygen, sulfur, and selenium always form a -2 charge. So some of these we know that, like if you see these common ones here, you know that they have just one charge, and so they go by the rules of what we talked about first. If you have a transition metal, or if you have tin or lead, it's very likely that you have an ion that forms variable charges. So then you need to use this Roman numeral after the first ion. If you're not sure, you can always look it up and see if what you're dealing with forms a variable charge. So let's look at Fe. So we have iron and chlorine. So the first thing we want to do is look up, okay, is this an ionic bond? Well, we have a metal, which is iron, and we have a non-metal, which is chlorine. So this is most likely an ionic bond. The next thing we need to do is say, okay, well, do any of these ions have a variable charge? Chlorine doesn't. It always forms a -1 charge, but iron can form, I already have it written here, it can form a 2+ charge or a 3+ charge. So what we need to do is work backwards. Well, for this compound, in order to name it, we need to know if this has a 2+ charge or a 3+ charge. And the way that we figure that out is to work backwards from this compound. So if we have, so first of all, we know that Cl has a -1 charge. So we have -1. And I'm going to actually write down all the chlorines. So we have Cl, we have 3 chlorines that all have a -1 charge. And I'm going to actually move this over here. So we have 3 chlorines that all have a -1 charge. If we add those up, we have a -3 charge. The charges always balance in these compounds, so if we add up the total charge in this compound, it's going to equal 0. So that means that whatever we have over here has to have a +3 charge. So then we have a +3 charge plus a -3 charge, and that gives us a total charge of 0. So we have one iron. We know that we need a +3 charge, so that means that this is Fe 3+. And so then the way we name this is we write down the name of our first element, that's iron. And since we're dealing with variable charges, we know that we need to put the charge of iron in Roman numerals here. So that would be 1, 2, 3. So we have iron 3, and then we have chlorine, and we go back to this rule where we have the first syllable of the second element plus "-ide". So this would be iron 3 chloride. Okay, so what I want to do at this point is summarize these rules a little bit better for when to use Roman numerals and when not to use Roman numerals for naming ionic compounds, and then I want to go through a bunch of examples. So I'm going to erase this. What I want to do is just say, okay, so when do you use Roman numerals for naming compounds? So when do you use Roman numerals to name compounds? So we use Roman numerals for transition elements and elements that form more than one ion. So use for transition elements and elements that form more than one ion. And so we don't use Roman numerals for elements that only form one ion. So don't use for elements that only form one ion. So this would be elements like sodium always forms a +1 charge. Magnesium always forms a +2 charge. So we always have Na plus, and sodium always has a +1 charge, and then Mg2 plus, and magnesium always has a 2+ charge. So we wouldn't use the Roman numerals for these elements because they always form they only form one ion. So they only form an ion with either a +1 charge or a +2 charge. Whereas if we have elements that form more than one ion, so for instance copper can form more than one ion as a transition element, and vanadium can also form more than one element. It's also a transition element. So you might be wondering, well, why don't we use the Roman numerals for these elements that only form one ion? The reason why is because we know there's only one option. We know what the ion will be that these form. For these other elements that form more than one ion, we don't generally know what ion they form, or we don't know what ion they are just by looking at them. And so now that I've given you these rules, I want to talk about a couple exceptions. Silver and zinc only form one ion. So what that means is if you have silver or zinc, you don't need to use the Roman numerals in your formula because they always form the same ion. Silver always forms 2+, and zinc always forms a 2+ ion. So for instance, if we had silver chloride, that would just be written as silver chloride. So we're using the naming convention with the element that only forms one. So we're using the naming convention assuming that the element only forms one ion. So we have the name of the first one, in this case it's silver, plus the syllable of the first syllable of the second one with an "ide" attached to it. So we have silver chloride. And then with zinc, let's say we have zinc and chlorine. So with this one, we know that it only forms one ion, 2+. So we write the name of the first one, so we have zinc, and then we write the first syllable of the second element and add "ide" to its name. So we have zinc chloride. So again, the reason why we don't need the Roman numeral after silver and zinc for these is because these only form one ion. So silver always has a 2+ ion, and zinc always has a 2+ ion. So now that we have some rules and some exceptions, let's just do a whole bunch of examples. So let's do copper. So we have copper and chlorine. So first of all, we want to figure out, okay, is this an ionic or a covalent bond? We know that copper is a transition metal. It's right here. So copper is a metal. And chlorine is right here. This is a non-metal. So chlorine is a non-metal. So what we want to do is, and the other thing is, so just looking at these, copper can form more than one type of ion. So copper can form a 1+ ion and a 2+ ion. So we have an element in here that forms variable ions. So we know that we're going to need the Roman numeral in this formula, or in this name. So for the first, so let's figure out what charge we have on copper. So we need to figure out which ion this copper is. So we know that chlorine always forms a -1 charge. So it's right here on the periodic table, and it always has a -1 charge. We have 2 chlorines, so we can write both of those. And if we add those up, we have a -2 charge. Well, we know that whatever we add to this, the total charge for this compound needs to add up to 0. So we know that this needs to be, the charge on the copper has to be a +2 in order for this to add up to 0. So we have a +2 plus -2 is equal to 0. So we know that this is copper 2+. So then we can go ahead and write our name. So we have copper, the first element is copper, and then we have it has a +2 charge, so we put the Roman numeral here for 2, and this is the Roman numeral for 2. And then we have a chlorine here, so the first syllable for chlorine is chlor, and then we add the IDE to the end, so this would be chloride. So this is copper 2 chloride. So I'm going to erase this and do another example. So now, and I think I'm going to erase this too, so there's more room for examples. So now let's say that we have copper and oxygen. So first of all, let's figure out if this is an ionic compound. We have copper, which is a metal, it's a transition metal, and we have oxygen, which is a non-metal. So we have a metal and a non-metal. So we know that this is forming an ionic compound. And we also know that copper will form 2 different charges. So it'll form a plus charge and a 2+ charge. So what we need to do, so we know that we're going to have a Roman numeral in this name because copper has a variable charge. And so what we need to do is figure out what the charge is on this oxygen so we can name this. Oh, and this is actually copper, so this is Cu2 oxygen. So let's write down oxygen. We know that oxygen forms a 2- charge, so we can write down the 2-, and so we have a -2 charge here, and we need to add something to this to get a net charge of 0, because we know that this compound has a net 0 charge. So we have a -2, and we know that we have 2 coppers, so let's put those here. So we need a +2 charge to balance out this -2 charge. And if we have 2 coppers, we know that each one of these has to have a positive charge, because when we add these together, we're going to have a net 2+ charge. So we know that the copper in this compound has a +1 charge. So the way we write this is we write the first element, so we have copper, and then we know that it has a +1 charge, so we write 1 in the Roman numeral. So we have copper 1, and then we have oxygen here, so this is oxygen, so copper 1, and then we take the first syllable and add "ide." So this would be copper 1 oxide. Okay, let's say that we have chromium and bromine. What we want to do is figure out where chromium is on the periodic table. It is right here. So chromium is a transition element, so we can assume that it has a variable charge. And so if you didn't know what the charges were that chromium can form, we could look that up. So chromium will form a 2+ charge, a 3+ charge, and a 6+ charge. So what we need to do is figure out, so we know that so this chromium is a metal. We know that bromine is a non-metal. It's right here. So we have a metal and a non-metal, so we know that this is forming an ionic bond. And so what we need to do in order to write the name for this compound is we need to figure out what charge this ion has that's forming this bond. So what we can do is write down the charges that we have for bromine. We know that we have 2 bromines, and we know that each bromine forms a -1 charge. So that means that we have a net -2 charge here. We need a +2 charge in order for this charge to balance out to 0. And we have 1 chromium, so we have 1 chromium here. We know that it needs a 2+ charge. So we know that this ion has to have a 2+ charge. So now we can write the name. So we write the first element, so we have chromium, and then it has a +2 charge, so we write the Roman numeral for 2. So we have chromium 2, and then we write the first syllable of the second element, so that would be bro from bromine, and add "ide" to it. So this is bromide. So chromium 2 bromide. I'm going to erase some of this and do a couple more. Let's say that we have manganese and sulfur. So first of all, we need to figure out if we have an ionic bond. So we have manganese, which is right here. That's a transition metal. And we have sulfur, which is here, so that's a nonmetal. So we have a metal and a nonmetal. So that means that this is forming an ionic bond. So what we can do is, so we know that this is an ionic bond, and manganese is a transition metal, so it's not one of the exceptions. Remember, silver and zinc are the exceptions. So we know that this will form multiple ions. So the ions that this can form are manganese 2+ and manganese 3+. So to write this name, we need to figure out which ion is being formed in this compound. So what we can do, we go back to the one that we know. We know what sulfur is, and we know that we have 3 sulfurs. So I'm going to write these sulfurs down. We know that sulfur forms a 2- ion, and it always does, so that's not going to change. So we have a net -6. We know that we have 2 manganese atoms, so we have 2 of those, so I'll write those in. And we know that we need a +6 charge here for this to add up to 0, because we have a -6 here, so we need a +6. So we have +6 minus 6 is equal to 0, because we know that this needs to have a net 0 charge. So the way to get the +6 here is if we have a +3 charge on each of these manganese atoms. So this would be 3+ and 3+. So then to write this name, we write the name of the first element, so that's manganese, and then we write the charge as a Roman numeral, so that's manganese 3, and then we have sulfur, so and remember it's the first syllable plus "ide", so this is sulfide. So this one is manganese 3 sulfide. Now let's do tin and fluorine. So this one's a little bit different because, well, first of all, let's figure out if this is an ionic bond. So we have tin, which is a metal, it's in the metals, and we have fluorine, which we know is a nonmetal. So we have a metal and a nonmetal, so we know that this is forming an ionic bond. So to name this, we need to figure out, okay, well, do any of these elements have multiple ions that they can form? Well, this one's a little bit tricky because before we were figuring out, okay, well, if it's a transition metal, it pretty much can form multiple ions. But it turns out that tin and lead and a few others act like transition metals in that they can form more than one ion. So it turns out that tin can form a 2+ ion and a 4+ ion. And if you didn't know this, you would just need to look it up and see if tin forms more than one ion. So we know that tin forms more than one ion, so we know that we're going to need the Roman numeral in this name. So what we need to do is figure out what the charge is on tin so we can figure out which Roman numeral to put in this. So first of all, we have fluorine, and we have 4 fluorines that all have a negative charge. So this adds up to a -4, and then we know that we have 1 tin. So we know that this has to have, so we need a +4 charge here because we know that the charge on this compound, the net charge, has to equal 0. So we know that we have to have a +4 plus a -4. So that, and we know that we have 1 tin because there's no subscript on the tin. So we know that this tin has to have a 4+ charge. So then how we write this is we have tin, and then we write the charge in Roman numerals. So 4 in Roman numerals is this. And so we have tin, and then we have fluorine, so we take the first syllable plus "ide". So we have fluoride, so tin, 4 fluoride. A few more. So the best way to get good at naming these compounds is to just practice doing a lot of them. So hopefully this video is helpful, and then you might want to find some other example problems to do as well, just to practice naming these compounds. So let's say that we have let's do cobalt, so CO3N2. So we're given this compound and we want to name it. So first of all, we want to figure out, okay, is this forming an ionic bond? So we have cobalt, which is a transition metal. So we have a transition metal here, and we have nitrogen, which is a nonmetal. So we have a nonmetal here. So we have a metal and a nonmetal, so we know that this is forming an ionic bond. And since cobalt is a transition metal and it's not silver or zinc, we can pretty much assume that it forms more than one ion. So cobalt will form a 2+ charge and a 3+ charge. So now what we need to do is figure out, so we know that this is going to have a Roman numeral after its name, so we need to figure out what that Roman numeral is. And to do that, we need to work backwards from what we know. So we know that nitrogen will form a -3 ion. So what we do is so we know that we have 2 nitrogens, so we write down the 2 nitrogens. We know that they form a 3- ion. So if we add these 2 nitrogens up, we have a -6 here. We need to balance out this charge so that we have a 0 net charge, which means that we need to add 6 to it, because +6 plus a -6 is equal to 0. We know that we have 3 cobalts, and we know that we need the charge on these to equal +6. So that means that each of these have to have a 2+ charge. So then what we can do, so we know what the charge is. We know that we have cobalt with a 2+ charge. And so now to name this ion, we write down the name of the first one. So that's cobalt. We write the charge as a Roman numeral, so that's 2. And then we have nitrogen. We write the name of, so the first syllable plus "ide." So this would be nitride. So cobalt to nitride. Let's look at zinc oxide, let's look at zinc and oxygen. So we want to figure out if this is forming an ionic bond. So we have zinc, which is a transition metal, and we have oxygen, which is a nonmetal. So we have a metal and a nonmetal, so we know that this is forming an ionic bond. And so we know that we have an ionic bond. So we want to figure out what the name is for this compound. So this one is is kind of a trick question, I guess, or this one's different from the others because we have zinc, which is a transition metal. So we might right away think, oh, well, it's a transition metal, so it's going to form more than one charge, and so we're going to need a Roman numeral after the zinc. Well, it turns out that zinc only forms one ion, and that happens to be a 2+ ion. So zinc will always form a 2+ charge. So even though zinc is a transition element, since it always forms a 2+ charge, we don't need the Roman numeral after zinc to specify what it is. And then we know that oxygen has a 2- charge, so 2+ and -2 adds up to 0. So the way we write this is zinc, and we know that we don't need a Roman numeral after the zinc because it always forms a 2+ charge. And then we have oxygen, so the first syllable plus "ide." So this is zinc oxide. And this is the reason why this is just zinc oxide and not zinc 2 oxide is because zinc always forms a 2+ ion, and we know that oxygen has a 2- ion, so this would be wrong. So when we write these names, the time that we need the Roman numeral is when we have elements that can form more than one ion. So we need to specify what the ion is in the compound. What I've talked about are how to name ionic compounds when you have monoatomic ions. So what that means is you have an ion that's made from a single element. So for instance, Na+ would be a monoatomic ion. So I have a list here of a lot of the polyatomic ions that can form. And what polyatomic ions are clumps of atoms that basically have a charge. So, for instance, nitrate has nitrogen and 3 oxygens, and it has a negative charge. Chlorate has a chlorine and 3 oxygens, and it has a negative charge. Carbonate has carbon, 3 oxygens, and it has a 2- charge. And I've circled the most common ones, but you'll see all of these. So for instance, hydrogen sulfate, which is also called bisulfate, has a one hydrogen, 1 sulfur, 4 oxygens, and it has a negative charge. One thing to notice with all of these is most of these have a negative charge. The exception is ammonium, which has a nitrogen and 4 oxygens, and that has a positive charge. These polyatomic ions can also form ionic compounds. So for instance, we could have Na2SO4. And what this is, so we have the sodium, which is a monoatomic ion, and then we have SO4, which is sulfate, and this is a polyatomic ion because it has more than one atom. And let's just look at the charges on these real quick. So first of all, the SO4 has a 2- charge, and we have 2 sodiums, which each have a positive charge, because remember, sodium always has a +1 charge. So we have a +2 here, -2 here, so the total charge on this adds up to 0. So the way that we name this is we write down the name of the first element. So we have sodium, and then we have sulfate. So we just write down the name of the polyatomic ions. This would be sodium sulfate. And this is simply just sodium sulfate, so we don't put the Roman numeral here, because remember, sodium only has a +1 charge. So sodium doesn't have multiple ions that it can form. It only forms a +1 ion. So let's do this one. Let's do iron. So we have Fe. So we have iron here. This is the monoatomic ion. And then we have phosphate, which is a polyatomic ion. So let's figure out the name for this. So first of all, we have iron, and we know that iron can form more than one charge. Iron can form a 2+ charge or a 3+ charge. So we know that we're going to need a Roman numeral in this name. So we need to figure out what the Roman numeral is. Well, we know what the charge on phosphate is. It's 3-. So we know that PO4 3-, and so we know that we have a -3 charge. We need to add a +3 to the -3 to get a net charge of 0. And we know that we have 1 iron, so we know that this iron has to have a 3+ charge. So we know that this has to have a +3 charge because we have a -3 here, so we have +3 - 3 is equal to 0. So to name this, we have iron, and I'm going to just write this here. So we have iron, so we have the name of the first element, and then we have the charge in the Roman numerals. So this would be iron 3, because we know it has a charge of +3, so we have 3 in the Roman numerals. And then we just put the name of this polyatomic ion here. So we have iron 3 phosphate. Do a couple more. Like I said, the way to get good at naming compounds is to practice naming a lot of compounds. And so that's what we're going to do. Let's say that we have aluminum 2 CO3 2. So first of all, we have aluminum, which is a monoatomic ion, and we have carbonate, which is a polyatomic ion. So carbonate is right here. First of all, just looking at this, aluminum always forms a 3+ charge. So aluminum doesn't form more than one ion. So we don't need to put a Roman numeral after aluminum. So the way we can name this is we can just put aluminum. So we put the name of this first element, and then we have a carbonate ion. So this is just aluminum carbonate. And again, the reason why we don't need the Roman numeral after aluminum in this particular example is because we know what the charge is on aluminum, since aluminum always has a 3+ charge. Now let's look at copper, and then we have NO2, 2. So first of all, we know that copper can form more than one ion. Copper can form a plus ion or a 2+ ion. And so the way to figure out the charge that we have on copper is we need to figure out the charge on what we know. So we know that this is the nitrite ion, and we know that the charge is, we know that it has a -1 charge, and we know that we have 2 of them. So this is showing the nitrite ion in parentheses with a 2 here. So this is saying that we have 2 of these ions. So we have NO2- and NO2-. So we have a -2 charge here. We know that we need a +2 charge for this to equal 0. So we have copper, and we have 1 copper, so there's no subscript here, so we know that we only have 1 copper. And we know that the charge on that copper has to be 2+, because the charge on the copper has to balance out the charge on these nitrite ions. So now we just write down the name. So we have copper, and since copper can form more than 2 ions, we need to put the charge as a Roman numeral. So we have copper 2, and then we just put the name of the polyatomic ion. So we have nitrite. Let's just do a couple more. So we have potassium, and we have the chlorate ion. Potassium. We know that potassium always forms a +1 charge. So this is going to be K+. And we know, so basically it forms 1 ion. Like we know that it forms 1 ion. So we're not going to need the Roman numeral on potassium. So we can just go ahead and write its name. So we have potassium, and then ClO3- is the chlorate ion. So we just write potassium chlorate. So we write the name of this first element, and then we write the name of the polyatomic ion. So potassium chlorate. And remember, the reason why we don't need the Roman numeral here is because potassium only forms 1 ion. Now let's do this one. So we have V, which is vanadium, CO3, 2. So just looking at this, so this is the carbonate ion, and this is saying that we have 2 of these. So carbonate's right here. So we have the parentheses around this with the 2 subscript. This is saying that we have 2 carbonate ions, and we have 1 vanadium. So vanadium can form more than 1 ion. We can have vanadium 2+, vanadium 3+, vanadium 4+, and vanadium 5+. So in order to write this name, we know that vanadium is going to have a Roman numeral after it to indicate what the charge is. So we need to figure out what charge this vanadium has. So we do that, first of all, we do that working backwards from what we know. We know what the charge is on carbonate, and we know that we have two of them. So we have two carbonates that each have a negative charge. Sorry, carbonate has a 2- charge. So we have two carbonates that each have a 2- charge. And so this is going to have a total charge of -4. And then we know that we have one vanadium. We know that we need a +4 charge to balance this out, because then we'll have +4 - 4. This is equal to 0. And so we know that this needs a +4 charge, so we know that the vanadium that we have is the 4+ ion. So then the way that we write this name is we write down the name of the first element, so that's vanadium. And then we write down the charge, so that's vanadium 4. And then we write the name of the polyatomic ions, so this is carbonate. So we have vanadium 4 carbonate. So just real quick, I want to summarize the rules of naming ionic compounds. The first thing you need to do is figure out, do you have an ionic bond? And remember that an ionic bond is a bond between a metal and a nonmetal. So if you have a metal and a nonmetal, you have an ionic bond, and so you're going to name this using the ionic compound rules. So then what you want to do is figure out, okay, well, does the metal form an ion with one charge, or does it form an ion with multiple charges? So if it forms an ion with one charge, the naming rules are that you're going to write down the name of the metal, and then you're going to write down the name of the first syllable of the non-metal and add "ide" to it. If you have a ion, so if your metal ion forms multiple bonds, then you're going to write down the name of the metal ion, followed by the charge as a Roman numeral in parentheses, and then the first syllable of the non-metal plus "ide." And then and then remember, the rules are a little bit different if you have a polyatomic ion in your compound. So if you have a polyatomic ion, first of all, you're going to figure out if the metal, so it's kind of going back up to this rule, so does the metal form an ion with one charge? If so, then you're going to have the name of the metal followed by the polyatomic ion name. If the metal forms multiple ions, you're going to have the metal name followed by the Roman numeral with the charge that the metal is in parentheses, and then the polyatomic ion name. So the best way to get good at naming these compounds is to practice. So I hope this video was helpful. Thanks for watching.